So far we have the fibbonachi.circom, and we were able to compile and generate .r1cs file. To proceed, we need two more files, Fibonacci or circuit.wasm file and also an input file. Let's go back to our programming environment to see how we can create these two files in order to go for witness generator steps. For the input.json file, we simply can create a file and write our fib1 and fib2 values in this file. Input.json, fib1 and fib2 17. As you remember, only the prover has access to this file. Also, to create the WTNS file, we use the circom compiler again. So we go to our fibonacci.circom code and then type circom fibonacci.circom. As you remember, the first switch was --r1cs, which generates a binary format r1cs constraint system for our Fibonacci circuit. And also the second switch is wasm, which produces a wasm file, which is a WebAssembly code needed for witness generation step. Moreover, we can create a symbol file by adding the --sim switch to the circom compiler command. It's crucial for debugging and displaying the constraint system. If we enter this command, circom compiler generates a .r1cs.sim and also a wasm file. But the wasm file goes to a new directory called Fibonacci_JS. Before going to the next step, I would like to introduce some more commands. The first command is snark.js r1cs info fibonacci.r1cs. This command displays statistics about the circuit, which curve is used, number of wires, constraint, inputs, and outputs. The next command is snark.js r1cs print fibonacci.r1cs fibonacci.symbol. This command is used to verify by printing the circuit's constraints. As you see, this is the constraints in our Fibonacci circuit. Also, to convert the r1cs file to a JSON format file for easier human interpretation, we can write this command: snark.js r1cs export JSON circuit Fibonacci.r1cs, then Fibonacci.r1cs.json. Now, if we go to this file, Fibonacci.r1cs.json, we can see a more readable constraint here. Now we are ready to go to the next step, which is a witness generator. To initiate the creation of the witness file, we use this command. Note Fibonacci_JS generate _witness Fibonacci_JS Fibonacci's wasm file, the input JSON file, and then we specify a name for our WTNS or witness file. By running this command, we can find our witness file in this folder. Also, to verify the compliance of the generated witness file with the R1CS file, we can use this command. snark.js wtns check fibbonachi.r1cs and then Fibonacci input WTNS. As you can see, the last message saying that witness checking finished successfully.